الأساسية لبناء السلامة الكهربائية يقدمها المهندس باري ريغان. المهندس ريغان مستشار في شركة ABB في المملكة العربية السعودية، حصل على درجة البكالوريوس في الهندسة الكهربائية بمرتبة الشرف، وعمل في العديد من الجهات ذات العلاقة في مجال توليد وتوزيع الطاقة الكهربائية والتحقيق في الحوادث الكهربائية والاستشارات لمنع الحوادث الكهربائية في عدد من دول العالم. Mr. Regan, please, and please monitor the time, 20 minutes max. Thank you.
Good morning, ladies and gentlemen. What I'd like to do this morning is really have a look at the foundations, the building blocks of power system safety, particularly looking at the advantages and functions of a regulatory system, and an example of a structure of the British version, and really looking at the basics of practical application and an example of a challenge and a solution in a multinational environment. Just first looking at an overview of the structure of legislation, regulations and standards. Of course, the legislation really is the command to take action on safety. The regulations tell us something about what we need to do to satisfy that command, and the standards are there to be met to satisfy the regulations. And this is on a widening base of information. And really sitting below this are all the detailed safety processes that are carried out at site level and in the workplace. The best advantage of legislation, in my mind, is that it puts safety on the agenda of government and business. It creates this framework of discipline to follow safety, and as such there are benefits to the whole of the population. Regulations work in three ways, really. The first, performance by design. We need robust power systems. We need power systems to operate under normal and abnormal conditions. We need systems to mitigate failures. Okay, we need systems to mitigate failures with regard to arc, flash and fire. Performance by design, protection from live parts, also protection from voltage appearing on what are normally safe parts of systems. We need safe work processes. We need to drive good practice. We need common processes for training. If we get common processes for training, we can get consistent standards of safety performance from contractors in the end. Finally, managing safety. If we don't manage safety into the whole of the work process, the whole of the management process, it will not really work in the long run. Typical requirements, training, competence, in other words, the ability to put that training into effective practice, and a key factor is risk assessment. We need to define clear responsibilities for safety throughout an organisation. And in all, we need to create this disciplined safety culture. This has been mentioned already this morning, and it's most important. The other aspect of managing safety, power system utilities. Power system utilities have huge responsibilities towards the public. So public safety, system security. Indirectly, system security affects the safety of the whole of the population. And of course, maintaining an infrastructure. Inherent in an infrastructure is the fact that the plant items have a long time life, so there is a need for maintenance over time. Standards are really quite different from this. They're the result usually of expertise, experience, and as we've seen, experimentation. They contain considerable detail, and the real advantage is they avoid duplicated effort in repeating research and experience. They provide a datum for manufacturers to supply consistent products, consistently safe products, and support the tender process in doing that. Standards also define good safety practice. have a difficult task to perform. We have standards and regulations, and they must be prescriptive to be effective. They must be reasonably clear in what we seek to achieve, but at the same time, in a real-world situation, they need to be practical. They need to be valid with time, the changes in technology, markets, and business organisations. We live in a constantly changing world. Looking at the British framework, which really very much mirrors what I've just said, we've got the Health and Safety at Work Act that sits at the top. It imposes duties and responsibilities on employers and employees. It requires a safe place of work for people. It requires safety instructions and policies to be formulated within businesses. And a key factor is that it implies a joint responsibility for safety between principals and contractors. It is not possible to entirely contract out all responsibility for safety. And it provides an enforcement authority. With regard to safe working, the electricity at work regulations, again, require maintenance of power systems that are fit for duty, power systems that can safely disconnect faults within them. It also requires design elements for safety, isolation, earthing, safe working procedures and safety competent people to carry them out. Management's very important. Again, training and competence in the whole of the safety world. Other subjects such as health surveillance, emergency procedures and risk assessments. We've talked about many standards, certainly for safe working on electrical systems. There is an EU standard, an EN standard, the operation of safe electrical installations. The enforcement authorities issue guidance on the interpretation of regulations, approved codes of practice, and there are many standards within the electricity supply industry. And the structure is that individual companies create individual sets of safety rules to actually work with their own processes. Trying to go down to real simplicity, we've got certain barriers to overcome. Regulations are typically written in legal terms. Standards, as we've said, contain considerable detail. And these things have to operate in a very wide, diverse range of activities and environments. And we need to address human factors, something else that's been mentioned this morning. For effective application, we need competent people, and we need this management process. We need to manage this safety through the whole of the work process. Mentioned something about risk assessment, and what I'd like to do is talk about it in very simplistic terms, because at the base of this it is a really simple three-stage process. We have a hazard, something with the potential to create harm. We have a risk. How likely is that to happen? How bad is it going to be if it does happen? And we have a control measure, or we have control measures. Effectively, what are we going to do about it? And it really is a very simple, basic process. It can be used in a very complex form, particularly useful as part of the planning process. But I'd like to think of it also as a very logical thought process, something that can drive behaviour, that throughout work, throughout the workplace, throughout the job, that people are actually continually looking at this hazard, risk, and what control. And this will help us put effective control measures in place, control measures that really do work. Taking an example in a multinational environment, the challenge was a spread of electrical accidents across a whole range of power system activity and in lots of different countries. There were different standards and regulations in those countries. There was inconsistent application of those standards. In some places, there were lack of standards at all, or certainly lack of standards that were evident and being used. And very often there is a business rather than a safety focus. And there was a need for some sort of common message, some sort of something to get round, something to bring us together in terms of electrical safety. So what we did, we took a look at common ground from various standards, various regulations that were in place. Basically, we use different words and different formats, but really we're all aiming at the same thing. So we wanted to find something, a simple message, something that would resonate with people in different countries and right around the world. We needed to market the concept. Safety is very much about winning the hearts and minds of people. We need to explain the logic if we're going to win the hearts and minds of people. People need to actually believe in what we're saying. Safety is very much about belief. And of course we need to support the application of controls. What we came out with is a very simplistic approach. We called this the 7 steps to electrical safety. So first of all, we had a sort of marketing tool. We had a nice name for it that we could market. And if I can share just some of the detail of this. So there were really 7 basic principles, 7 simple sentences that talk about actual safety processes when working on high power systems. Clearly identify the situation at the location. This leads into risk assessment, identifying hazards and starting the risk assessment process. It leads into carrying out proper planning for safety. At a detailed level, it talks about marking out safe and dangerous areas within the workplace. The second one was disconnect and secure against reconnection. And this is a well-known industrial process, a process of lockout and tag out. Thirdly, protection against live parts, and really that's what we're about all the way through, isn't it? We define safety clearances. People's judgment, individual judgment, is very poor when it comes to judging how close we get to something, how close we work to something. We reinforce those with barriers. If necessary, we reinforce those with supervision because we need to assess the level of the people that are in danger. Inherent in the process of safety controls on power systems is sometimes getting quite close to the source of danger. So we need to be aware when we're going into these areas. So when we're close to live parts or parts that may be live that haven't been proved, we need to take additional precaution. And that's normally in the form of additional personal protective equipment. Check the installation is dead. It sounds pretty obvious really, but in fact the failure to do that is often at the root of many, many incidents. And we always do this, and by a fail-safe method, because we're checking for the absence of something. So it's important that we have a proper methodical approach to this. Grounding, earthing, we discharge any residual voltage in equipment. We maintain a safe potential throughout the whole period of that work. And finally, a permit to work. This is all about control of the workplace, control of the people and of the process. It's a written permission to work. It's a clear communication of conditions and of responsibilities for safety at that point. Verbal communications are not particularly good. And bearing in mind how dangerous, essentially inherently dangerous power system work is, we do need to be very clear when we're carrying out instructions. So these were the principles, the things to be achieved. In fact, they can be applied to most power systems at most voltages and a whole range of activities. The actual processes for applying them will differ, but they can be applied. And applied in full, they provide a multi-layer defence. We have to accept that electrical defences or defences of any kind are fallible. Things go wrong. We need to mitigate failure in some defences. So, for instance, failure in the lockout-tag-out process would be partially mitigated by having grounding connections on equipment while we continue to work.
Engineer Regan, time please. You have 15 minutes.
Okay.
Thank you.
They can be memorised as a personal checklist, so they can help drive behaviour and this disciplined safety process. They can be used to raise awareness in the management team and set minimum standards and used as a foundation for electrical safety rules. They need management support with safety equipment and an electrical safety culture. They were launched with videos, training and an explanation of the process. They're not a new idea and not a perfect solution to everything, but they've been found to be a powerful tool in getting the message out for electrical safety. So the standards, regulations and legislation has a vital role, but they need turning into effective practical guidance at the workplace level and within the management process, and a part of a disciplined electrical safety culture. Thank you.
Well, thank you, Engineer Regan, for helping us stick to the time.